Many of us have seen these images, and some of us have lived through them. This is what happens in cities during floods. And what we see here is a series of failures propagating through urban infrastructure and communities. High winds take down the power grid and cities plunge into darkness. Power failures disable pumps and valves within the combined sewage system, and raw sewage backs into people's homes, creating public health hazard. Wastewaters overflowing onto the streets combined with existing stormwater runoff, flooding buildings, rendering the roads and bridges impassable to traffic. The same power outages may disable operations of the drinking water system, and people cannot access clean drinking water at a time when highways become waterways and the trip to a store is impossible, and neither is evacuation. Floods and other climatic events that cause flooding were the highest among all disasters in the last century, as you can see in the graph on the left. On the right, we see that economic damages and corresponding fatalities have been increasing due to floods. And in 2017 alone, the cost topped $60 billion. So despite all the work and research, we still cannot predict how flooding impacts cities and how these failures cascade. Why is that? Cities are highly complex systems, and they include multiple layers of infrastructures, including transportation network, the power grid, and water systems, all of which are intertwined with socioeconomic and public health sectors. And all these systems are connected. Within each one of these subsystems, there is a wealth of data and models that have been accumulated over decades, but this information is not connected. And that is why we cannot predict the cascading failures and the total impact of floods on cities. A manifestation of this lack of data connectivity is what you see when you do an internet search, flooding near me. We did this query from Santa Barbara, California in 2020 using Google, you see that on the left, and Bing, and you see the results on the right. And the results using both of these search engines are 3 years off and half a country away. For example, you see here reports from 2017 and 2018 about floods in Texas and the Midwest. So there is no temporal or spatial scoping for these flood responses, and it renders them irrelevant and inactionable. To solve this problem, we have developed the Urban Flooding Open Knowledge Network, an information infrastructure that is built on top of modern search engines like Google or Bing. And what it does is links the real-world urban infrastructure that you see pictured on the left to dynamic flood predictions that you see pictured on the right. And the result is that now UFOCAN represents the relationships within connected urban systems and links them to flood forecasts. Furthermore, the UFOCAN is extendable in the future to any forecasting model and any new urban infrastructures with their own cascading impacts on the cities. So what we're striving to do here is develop a technology that will provide meaningful information when you type in flooding near me. It will produce spatially and temporally relevant information on emergency guidance, on local road closures, available shelters, flood warning, and it will deliver it to your fingertips. So this is the future. We started out in 2019 and 2020 with 2 user workshops with a total of about 80 participants, and some of you have participated in one or both of those workshops. And in these workshops, we employed human-centered design to make sure that the UFOCAN was not only viable, but actually useful in practice. From participant feedback, we grouped our users into what are called personas. You see here an urban planner, utility managers, emergency response managers, federal employees, etc. And these personas serve as proxies for all the real users from our workshops. They capture details about the scenarios in which these personas want information from the UFOCAN. These details, such as their traits, goals, behaviors, pain points, and needs help us make design decisions for how UFOCAN information should be uniquely delivered. For example, we learned that Emergency Erica, who is emergency manager, makes quick and adaptive decisions for fast, efficient deployment of first responders. Her pain points are not having timely and accurate information as she manages this response. She needs real-time flood forecasts of both the flood extents and its depths. Erica's profile helps us ensure that the UFOCAN is effectively delivered to emergency managers within their real-world experiences. And by building out more portraits across 7 other personas, we identified potential users and how the UFOCAN can positively impact their roles. In the next year and a half, we will make the pilot UFOCAN scalable, operational, and sustainable. And it will be used by a variety of users, including our partners and stakeholders, to obtain flood-related information through their device of choice. Here you see just some examples of how the UFOCAN will be used. For example, Buyer Bob is on the top left. He's a potential homeowner and checking out flooding history in the new neighborhood. He wants to find out how many homes have experienced flooding in the recent past and when. A private citizen, Nervous Norman on the right, may use his smartphone to find a safe driving route during a flood. Emergency Response Manager, Emergency Erica on the bottom left, could interact with the UFOCAN through her computer to find areas that are at flood risk. We will be scaling the UFOCAN to continental US, and we will do that through pilots at city, county, regional, and national scales by working with partners that you see listed on this slide. If you do not see your organization here yet, please know that we would love to work with you.